Hello.
Yeah,
Hello. Good afternoon to everyone.
Yeah, good afternoon.
Yeah, welcome all participants, and I welcome the expert person for this session, Dr. Sachin Borse from JSPM University, Pune. Welcome, Dr. Sachin Borse, sir, and thank
Yeah,
you
good
for
afternoon.
accepting
Yeah.
our invitation and contributing to the success of this FDP, which is AICTE sponsored on AI-driven advances in mechanical engineering. I'm really thankful to you personally. Thank you so much, sir. I now request my colleague Dr. Ullas Tonde to proceed ahead.
thank you, sir. So, dear participants, I welcome you all in this 13th session of this faculty development program.
Sir, your voice is coming very low.
Faculty development program on AI-driven advances in mechanical engineering. So, I would like to take this opportunity to introduce today's resource person, Dr. Borse, sir. So, sir, presently, Dr. Sachin L. Borse, sir, is working as a professor at JSPM University, Pune. Sir has the qualification like BE from the reputed university and the PhD in mechanical thermal fluid engineering from the IIT Bombay. Sir has more than 30 years of experience in teaching field as well as the industry. Sir has the experience in industries like Mahindra Eugene Steel Company Pune, KSB Pumps Pune, VJ Craysoft Private Limited Pune, and sir has the teaching experience in the reputed institutes like JSPM University, then Imperial College of Engineering and Technology, Pune, College of Engineering and Shakra University, Saudi Arabia. Sir has also experience in Rajarshi Shahu College of Engineering, Pune. Dr. Borse has many awards in the field of teaching. Sir has delivered uh, more than 50 sessions in the conferences, in the workshops, and the FDP programs. Sir has also guided several BME students and the PhD students from 2007 till the date. Sir has also attended several workshops from the IIT Bombay, TCS, and Nano Aviation Private Limited, Chennai. And sir has also handled several reputed funded projects from the governments and the non-government organizations. Sir has various achievements and sir has published more than 20 research papers in the Scopus Index journals and the conferences. In this way, sir has a wide range of experience, achievements, and the research achievements in his career. So, I would like to welcome you, sir, on behalf of Sriyash College of Engineering and Technology, Chhatrapati Sambhajinagar, Maharashtra. So, sir, now I would like to hand over the session to you, sir. Please proceed with the expert talk.
Thank you. Thank you for your nice introduction. I would like to share my PPT. So please permit me.
Tonde, sir, make him a co-host. Borse, sir, now you are co-host. You can share your PPT.
Yeah. Can you see my PPT now?
Yes.
So I'll just
Yes, sir. Now it's clear.
Yeah, is it visible now?
Yes, sir. Yes, sir. Visible.
So, I am very thankful for inviting me to share the lecture on AI for centrifugal pump. I was earlier, I was related to the KSB pumps. I was there and I was doing CFD analysis. But now AI is helping now for CFD analysis as well as for optimization. Okay, so first we'll enter. I will make in the three steps. First, AI. What is AI? Then we'll move to the pumps, and then we'll move to the application of AI for pumps. Okay, so we'll understand what is a intelligence and what is the artificial intelligence. So we'll go to the artificial intelligence. The short form for artificial intelligence is AI. So John McCarthy defines AI as a science and engineering of making the intelligent machines. Okay, so it is a science and engineering of what? Making the machines intelligent. Okay, so we want to make the machines intelligent. Okay, so let us understand here what is meant by intelligence. Okay, so that we'll see in the maybe next slide. Okay, so in simple language, what we want to do is with the AI, we want to make the machines to take their own decision. Like whenever there is any computer program, so there is a decision loop, but decision loop is not decision actually. Okay, please understand here. In program, any program, whether C program, Fortran program, there is a decision loop, but decision loop is not decision because it is the instruction or order given by us. If this is this, then do this. If this is this, then do that. Okay, so that decision is not decision. Okay, it is a order given by us. But what we want machines to take their own decisions. Okay, that is the purpose of AI. Okay, so I've given here, unlike in computer program, machines activities based on our order or instruction. Okay, so it is not decision taken by the program. There is no decision taken by the program in the normal computer program. But what we want machine to take its own decision. Okay. Now, whenever we talk about intelligence, okay, when we talk about artificial intelligence, when we talk about intelligence, we should understand what is meant by intelligence. Okay, so what is an intelligent person will be which can face any environment and take the decision. That is the intelligence. Okay, meaning of intelligence. So we'll see what are the characteristics that defines the intelligence. First, ability is to take the decisions. Then next is the learning. Okay, to ability to learn and experiment. Then comes ability to think, represent the knowledge, ability to think and act rationally, ability to perceive, reason, plan, and act. So this all we can say the set of characteristics defines intelligence. Okay. So first is ability to take the decision. And second is what? Learning. So many time in academics, the student who is able to learn, we call it as a intelligent. Okay, because he is one of the important ability to learn. Okay, suppose I want to send one spy to Pakistan. Okay, so what he should be? The person, he or she should be what? Intelligent. What is intelligent means? he or she should able to learn the customs. Like in India, majority of the officers, maybe as majority is Hindu, the majority of officers may be Hindus, and they want to go as a spy to the Pakistan where the majority of persons are Muslim. Okay, so here intelligence means the person should adopt to the Muslim culture as well as language culture as well as customs. Okay, the person who can adopt this effectively. Okay, so will be suitable for this post. Okay, so if you see intelligence, one of the main characteristic for intelligence is learning ability. Okay, so here that we want to do in the artificial intelligence, that machine should able to learn. Okay, and then take the decision. Okay, now we'll see the applications of artificial intelligence. There are many applications, and day by day the applications are increasing. Okay, as we gain the knowledge and experience, the applications are increasing. Okay, like we can say the challenging application is playing the game against the human opponent. Like suppose you want to play the chess, then AI can play the chess with you. Then creating the expert system. Like suppose you are the ill, and then you go to the physician, that is a doctor, and then you tell your symptoms. Okay, so doctor also uses torch and tells you to open your mouth. He observes your tongue color. Okay, and whether there is any inflammation in the mouth. Okay, so all this we can say the parameter he observes, and based on his experience he prescribed the medicine. Plus he diagnoses what is the you are suffering from, and then he prescribed the medicine. Okay, so that is the expert system. Shortly we will get such expert system, and that is actually affecting the doctors, because the expert system will be cheaper than what the doctors are charging. Okay, then natural language processing. Now, what happens? The language changes every 10 kilometers, 20 kilometers, or say 50 kilometers. Okay, like Marathi is spoken in the Pune, Nagpur, Naga. It's very different. Okay, so we need something intelligent system to understand the different dialects and then process. Then comes the robotics. So whatever a robot you see in the industry, like robotic arm, so it is not actually robot in that sense, okay? Because it is not taking any decision. It is just what is it is doing? It is just running the program. It is not taking the decision. But real robot will take the decision and act accordingly. Okay, please understand it. But new robots, humanoids, they are in that sense they are robots. They take their own decision. Then comes e-commerce, like Amazon. Amazon keeps the record of you as well as other customers, and suggest the appropriate, you can say, product to you. Like suppose you are purchasing mobile, then we can say is database is showing that when we purchase, someone purchase mobile, he or she also purchases mobile cover, power bank. Okay, and accordingly the Amazon will suggest. Then comes social media. In the social media, like Facebook, he will identify you in the picture, of your friends, and it will tag you. Okay, so that way the artificial intelligence is helping. Okay, but here please understand one important parameter here. The experience is important. So what the experience, or we can say training we give to the AI, it is very important. I will give one simple example. Like your mother watches you throughout your life from the birth till today. So she knows from her data what you like, what you dislike. Okay. So it is type of the training. Okay. So many people say, I will use AI, but here, please understand the training is very, very important. Suppose if you cannot give the training, you cannot use the AI. Okay. If you not giving proper training, you cannot get the proper outcome. Please understand. Suppose we know that in we take the expert system example, doctor or physician, the many patients come and they have the very similar symptoms like the person will have fever, headache, body pain. Okay, so these are very, very common. So to guess or to identify disease is very, very, we can say expert thing. Okay. So unless you properly train the AI, there is no output. Okay. So training of AI is very crucial, important. Proper data need to be given, and then we expect the good outcome. Okay. Now, there are machine learning, there are approaches like supervised learning, unsupervised learning, reinforcement learning. So when we say supervised learning, so like suppose you go to any industry as a fresher, they will tell you this is a lathe machine, this is a milling machine. The same thing here. We tell the software like that. Suppose we want to classify the animals. So we'll train the AI how the dog looks like, how the cat looks like. So we feed the pictures and also tell the AI to remember this as a picture of dog. This is a picture of cat. Okay. So we provide it is in the computer language. We say it as a label data. Okay. So we feed the data into the model. It adjusts its weights until the model fits appropriately. Okay. So one more thing that I will highlight here, that AI cannot be 100% accurate. Please understand here. AI cannot be 100% accurate. So if you get 85 or 95% accuracy is good, but please understand AI is not God. AI is based on the experience. Okay. So better the training, better will be outcome, output. Okay. So supervised learning, we provide the data with the labels. So that is the supervised learning. You can see here different cat and dogs photo will give, and after training, we will also validate it. We'll randomly give the different picture of cat and dog. Okay. Then comes unsupervised learning. And unsupervised learning, we don't train it, we don't provide the level data. But what it does is it makes a group. Like I will feed the photos of dogs, I will feed the photos of cat. So in unsupervised learning, it will make what is called as groups. Okay, it will make the groups. Okay. Then I mention one thing that one of the important characteristic of intelligence is learning. So there is a subset of AI, artificial intelligence, that is machine learning. Okay. So what we have to do is we have to enable machine to learn. Once it can learn, it can take decision. So machine learning is a subset of AI, and its purpose, this is computer algorithm, and its purpose is to learn and perform the specific task. Machine learning is about learning by machines to do better in future based on what we experienced in the past. Okay, so I will a little bit throw the light on what we want this automatic decision is like I will give an example. Suppose I am driving the car at very high speed and I observe the pedestrian, some person walking on the road. I observe it, so it will take 1 second. Then I will give the instruction to my foot to press the brake pedal. So this all together will take almost 2 seconds, and in 2 seconds, if it is high speed, it will get a very huge distance. But if it is a machine learning or automation, in that it will detect the object, it is identify as an obstacle, then as per training it will suggest to apply the brake, it will slowly apply the brake. So in computer language the processing very fast, it will do it in within the fraction of second. So because of this it can save the life. So sometimes machine decisions are very faster than human decision. Okay, so we train the machine to learn from available experience. Okay, so machine learning is we develop the programs that analyze the data from various sources, select relevant data, and use the data to predict the behavior of the system in a similar situation, or we can say if different situation if possible. So machine learning classifies objects and behavior to finally impart a decision for new scenarios. The interesting part is that more learning and intelligence is required to deal with uncertain situation. Please understand it. Okay. Every time the situation will not be same, but it will be different. So machine learning is, we can say it is a computer algorithm that allows to computer to learn automatically. Please understand, to learn automatically. Okay. Someone is not giving training, but what the it is given, the data is given. Please understand it. Okay. From the previous interaction with the users, without being distinctly programmed, without programming. Okay, please understand. Yet make it a clear difference between computer program and AI, or we can say machine learning is, in computer program every decision is given, even though it is a decision loop, but the decision is already given, already ordered. But in the machine learning or AI, the decision is based on previous experience. Please understand it. Previous experience is very important here. So decision is made on previous experience. Okay. Suppose we take the example like I am training my AI, which is fitted in my car in Pune city. And you know that Pune city, the majority of people don't follow the traffic rule. So whatever I train it will work accordingly. So if I train AI to break the signals, so it will obviously it will break. Okay. So whatever we feed, whatever training data we provide, it will act accordingly. Okay. So it gives computers the skill to learn from previous data without the expert having to program it. So that is the machine learning. Now next comes the deep learning. So this is again you can say subset of machine learning, and it is based on the neural network. So neural network it is mimicking, or we can say it is copying the behavior of human brain or animal brain to learn. Okay. So deep learning is a subset of AI subset is machine learning. Machine learning subset is deep learning, DL. Okay. So this uses neural network that exist. It mimics, copies the behavior of a human brain. Okay, so it allowing it to learn from large amount of data. So like you have many neurons network in the body and it is connected to the brain. Okay, so different we can say large network. So it will learn. So neural network with the single layer that can be different layers in between. Uh, so single layer will not be sufficient. Okay, so additional layer can improve the performance. Generally, three layers are people say that is enough. Deep learning eliminates some of the data processing that is typically involved with machine learning. So weightages are given. So it eliminates some data processing that we'll see in the next picture. This algorithm can deal unstructured data, okay, like text, images, and it can automate the feature extraction. So that is sometimes needed by the human expert. Like you can see the picture here. In the deep earlier in machine learning, we need the human we can say involvement to extract the features and then classify. But here the feature extraction in deep learning is done and then classification is done. Like here we want to identify whether it is car or not car. So you can see here AI, then ML, and then DL. So this was the introduction of artificial intelligence. So I will again tell you that the good data is needed to train the AI, then and then it will work. Okay. So we will move further. Now we'll move to the pumps. So pump, centrifugal pump is a turbo machine. So turbo machine can be either power or head generating. When it is power generating, means it is a turbine. When it is a head generating, means it is a pump. Okay. So what it does is it provides dynamic action of rotating element, that is a rotor, and action of the rotor changes continuously uh, flowing fluid through the turbo machines. Okay. So either impeller, when impeller acts on the water, it develops the hair. When water acts on the rotor, it is the turbine. So we'll move to the centrifugal pump. So centrifugal pump uses centrifugal action. When water moves in the impeller, it is thrown out. So when it is thrown out, its radius goes on increasing. And because of this, it achieves a larger velocity at the larger radius. And that velocity, when we can slow it down, we know that pressure can be converted into the vessel velocity can be converted into the pressure, and that pressure is converted into the velocity in the diffusing passage. Even the diameter, when the width is constant, but what happens as the radius is increasing, the passage is what is called as a diffusing passage. And this velocity is converted into the pressure energy. So we get, because of the dynamic action, rotating action of the pump, the pressure. Okay, so centrifugal pump is a very important machine, and it's account about the 20% of world's electrical energy. So optimizing the pump for improving the energy efficiency is very important, because of our total energy consumption by machinery. The pump accounts for 20%. Okay, so these centrifugal pumps are of two types: diffuser pump and volute pump. Okay, when it is a single stage, it is a volute pump. So there will be spiral volute outside, and when it is a multi-stage, it is a diffuser pump with the vane diffuser at exit. Okay, so if you see from the CFD point of view, just we'll go to see the photos. So this is a CFD simulation of, we can say, impeller pump. Impeller pump is a single stage pump. We can see here. I will just, okay. So you can see the impeller is rotating, and outside this impeller, this water is collecting and it is going. Okay. So as the water is going out, its pressure is going on increasing, and because of this, there is a net, you can say, radial thrust. It is shown by red color, red arrows acting on the impeller, and that is transmitted to shaft. So there is a, you can say, net radial thrust acting on the impeller. Okay, so we need CFD to evaluate this radial thrust. Okay, so this is a, first pump that is called as volute pump. Now we will move to the diffuser pump. Diffuser pump is a multi-stage pump when there are many stages. So it is generally used. After the impeller, this is the rotating component. Rotating component is called as what? Impeller. And after impeller, there is little gap, and there are fixed vans. These vans are not moving. This is called as diffuser. And here, what is happening? The velocity is converted into the pressure, and then it is fed to the next stage. Okay, this is the diffuser pump. Okay. So one more thing that pump will experience is axial thrust. We saw the radial thrust, and now there is axial thrust. If you see the diagram of impeller, to the back side there is a fluid, and it is acting throughout the radius. But if you see the front side of this impeller, the water is only this much. So it is, the water is acting here in the casing. The water is acting. Please understand here. Okay. So there is a recirculation of the fluid in the gap, and you can see, if you see this plot of pressure. and plot of pressure. If you find the net force, so there will be net force from shown in the red color from the right to left. So there is a radial thrust as well as axial thrust, and this gives rise to the net force and on the bearing of the pump, and it needs to be evaluated through the CFD. Okay. As more is axial and radial thrust, it will affect the life of bearing. If it's more, then it may need the frequent replacement of this bearing. Please understand here. Now, one of the we can say the phenomenon that is happening in the pump is cavitation. Okay, we know that at the room pressure, or we can say atmospheric pressure, the water boils at 100 degrees Celsius. Okay, but we go higher and higher, like we go to the Himalayas, where altitude is high, and because of that, atmospheric pressure will be less. So there, the boiling point can be less than 100 degrees Celsius. So the boiling point, please understand here, the boiling point of any fluid depends on the pressure. At 1 bar, you can say it is 100 degrees Celsius, but if it is reduced, it will start boiling at lower pressure. So if you see the diagram here, just move to the diagram again. So if you see here the diagram, the water is coming through this, okay, and it is sucking there. Whenever there is sucking action, because of this inlet pressure is less, okay, and it will go below atmospheric pressure. Again, below, still what happens? So water can start boiling at the room temperature. Okay, so it reduces to the such an extent that water can start boiling. Okay, so once it boils the water, what happens? We know that the density of water is 1000 kg per meter cube, but maybe the steam having maybe 2-3 kg per meter cube. So if you reverse that, the volume is almost 1000 times. The steam is having the volume 1000 times than that of the water, and so it forms a bubble. And if you see the picture here, this bubble will go to the region where you can see there. This arrow is having the more length, and so there is more pressure. And when it goes to the pressure, higher pressure region, what happens? The pressure is higher. So we know that the pressure is higher, it will condense. Okay, because at that pressure, we need the higher temperature. So it will condense. And when it condenses on the surface, suddenly what will happen? Where during condensation, it will create one cavity, vacuum, and the water from all the side comes and hit this surface, causing the damage. It is a repeated, and it will create vibration. It will create reduction in performance, like uh, the pressure of the water will be less. Okay, so the cavities, we can say this is called as cavitation. So this is, we can say, the should be avoided, and for that we sometimes we simulate this with the CFD. Okay, so one of the we can say the performance related thing is the cavitation. Okay. So cavitation should be avoided. It can create noise, vibration, and of course, it reduces uh, performance, like head. Okay. Uh, Now we know that pump can be also used as a turbine, although its efficiency cannot be good as the machine which is designed as a turbine. Okay, so pump can be also used for turbine, or in case of accident, like so pump is not working, it's stationary, and suppose some water comes or some fluid comes, it will start rotating. So what will be its performance? Okay. So, in such a accidental case, please understand, your pump is connected to some line, and there is some flow coming accidentally to there, and it will work as a turbine in that case. And what we want to find is a runaway speed. What will be the maximum speed it can obtain, because it is also connected to some machine motor. Okay. And we expect that it will not rotate, and it is rotating. Okay, so in that case, we want to know what is the RPM, runaway speed of pump as a turbine, what is its performance, or we can also use sometime when the efficiency is not important, we can use pump as a turbine. Now comes one important, you can say, important of optimization. As I mentioned, the pump consumes very huge power. The pumps we use in the pumping station, they consume very huge power. And if their efficiency is less, it will affect municipal corporation, because there will be huge bill, and also it affects because that energy will not be available to other people. So we optimize pump to improve hydraulic efficiency, reduce the losses, and of course, when there are some problems like cavitation, cavitation creates vibration, and because of vibration, the life of machine is affected. Okay, and support the sustainable and cost effective operation, because if it is not efficient, it will affect the performance, and as well as the operation cost. For pump, the electricity is our operation cost. Now we'll see what are the challenges in the traditional pump design. Okay. Uh, First, I will see that, and then I will also describe about the CFD challenges in traditional pump design. Okay, so when we start pump design, so we design as the best, you can say, best efficiency point. Okay, but when we take the test, it will be a little bit shifted. Okay, so for the pump, it is very complicated flow, because there is rotation and we can say churning. Okay, so simulating such a flow is difficult. Okay, also it is a time consuming, computational expensive. If you go for transient simulation, it will be very, very costly, because it require a lot of time and storage also. So what people earlier, like I was in KSB pumps, what they do is they do the trial and error for any hydraulic design. They do many, you can say, cases, and then they test it, and then they select the best one. So that is the call as trial and error method. Also, there are some methods the book describes some, we can say, empirical methods for designing the form. Okay. Now, how AI can help, and rather people are doing that. I will send you one paper, review paper. They have discussed various methods people are using, like neural network, artificial neural network, for pump design or pump optimization. So, machine learning algorithm can learn the data can learn from the data and predict pump behavior. Suppose our pump family is, we can say, similar geometry. Okay. Then if you feed, like, there can be scaling, like the pump you are using for your household is just 0.5 HP. But if you whatever you use for uh, city water supply, the PMs are big. Suppose they are from the same family, then we can train our AI based on their performance parameter, head, discharge, NPSH. Okay, NPSH 3%. Okay, so NPSH 3% is the data. We what we do, we go on reducing the inlet pressure so that it start cavitating. Okay, so we do this till is we can say the head reduces by 3%. That is called as NPSH 3%. So such similar families. We can feed data, and between the two ranges, like I told, small pump and big pump, we can, in between size performance, we can predict with the AI. Okay. So we can also use neural network for nonlinear relationship reinforcement learning to optimize operational strategies through error trial and error method. Okay. So you can use AI for performance prediction. Okay. Please understand, if you observe from we can say curve. Just I will draw the curve. It is like this. Okay. So on the is correct. It's on the x-axis, it is a Q. On the y-axis, it is the head. Okay. So as we increase it reduces. Okay, somewhere there, and also we can plot the efficiency graph. Okay, so what we do generally, we design the system in a such way that for operating condition, it is near to the best efficiency point. Okay, so our purpose is, suppose if you operate near the best efficiency point, then your energy consumption will be less. Okay, so we have to either select the pump for your system, because if you give your parameters and accordingly then select your pump, then it will operate at the base efficiency. So, one more another category, we can say another way is to vary the speed and to match to the base efficiency point. So for this, AI can take the decision and convert to the variable speed motor. So AI can be also used for fault diagnosis and predictive maintenance. For this, we need to fit the sensors. Now, sensors are relatively now cheaper, and if your pump is not operational because of some reason, so downtime can affect your production. Okay, whether it is chemical industry or mechanical industry. So, if you analyze, you can call again condition. If you do the condition monitoring of the pump and repair it before there is a major failure. So here the AI can help you based on the data. What are the chances of failure from the noise, from the temperature? Okay. So it can help, we know that if you see the aeroplane engine is continuously condition monitored to see whether there is any problem, because we have recently seen one case in Ahmedabad. There was crash of aeroplane because of sudden shutdown of the fuel supply to the engine. Okay, so for this reason, they continuously monitor. Same thing is here for pumps. We can also monitor like a big pumps in the pumping station. If they are down, what will happen? We cannot supply water at sufficient flow to the city. Okay. When we fault diagnosis and condition monitoring, so we reduce what is called as a major breakdown. Okay, like if this is continuous, we can say cavitation, it will damage the impeller, and the cost of impeller for big pump will be very huge. So we have to avoid the cavitation. Okay. So in optimization function, there are some papers. What were the targets? It is mentioned like here, the target was objective optimization function, or you can say target was energy saving to broaden the high energy efficiency zone. Like in the, you can see the efficiency curve, it will something like this. Okay. So here this range should be greater so that it can work for some range of the flows. It should work for best efficiency. Okay. So these were the objective functions for optimization using the AI. Then what the optimization different other than AI, what they were using: traditional method, inverse design, Bezier curve, noobs. Okay. Then implementation of machine learning algorithm for pump optimization. I'm just deleting this. Okay, so we have to define the uh, problem. What is the objective function? What are the decision variable? Then we have to generate the sample. Okay, then we have to conduct the machines learning, and then you go for the optimization. As I mentioned, majority of papers are using ANN for we can say machine learning and genetic algorithm for optimization. Okay, so we'll move further. So what are the challenges, limitations of AI? So as I mentioned, AI itself is nothing. AI itself is nothing. What we need is, we require high quality data for its training. So as I mentioned, if you give the bad data, it will give the bad prediction. Okay. It is just like a sanskar. So the way you give the sanskar, in the same way, the training data is a sanskar for AI. Okay, so if you so we require extensive high quality data for effective model training. Okay, and there is complex fluid structure interaction in the impeller and impeller when casing and diffuser, so that gives the challenges. So also when we talk about the AI, we need the expert. At least at the initial phase, still your engineers, managers learn to use AI. Please understand. Suppose I have one AI software, but what I need is I need to give the training. For training, I will need some experimental data. Okay, either I need to purchase or I have to create the data for its training. Once the training is done, it will work. It will work very nice. Okay. Then next come digital twin and future trend is AI hybrid system. So digital twins, it is used in various field. It is a virtual replica. We can say it is a what is called as mathematical model of your palm. Okay. And this model is continuously upgraded with the continuous monitoring and simulation. Okay. AI, you can, if you integrate with the digital twins, okay, can enable proactive operational adjustment. Okay. So digital twin is what? Digital twin is, we can say it is a mathematical model of the system. Like it's a POM, it is a mathematical model of POM, and that model is updated. Like it is not the single model, it is updated regularly. Because what happens, the given POM, its performance will, we can say, reduce day by day, and this model, this digital twin will updates its model accordingly. Okay, and if the AI work with this digital model, then there can be operational adjustment we can do, and we can do decisions based on that. This digital twins model and AI work together and can take the decision required for better performance and avoiding any noise. Okay. Now we can also integrate AI with the smart manufacturing and predictive analytics. So AI-driven predictive analysis can optimize supply chain, maintenance schedule, and quality control. Okay. Smart manufacturing leverages AI for adaptive process control, supports Industry 4 transportation in the pump manufacturing. So it will give suppose there is some indication of condition monitoring that your bearing may fail because of the data received. So it can automatically set up the requirement to the supply chain, so that even it is chances of failure of the pump, we can replace the bearings before there is any greater damage. Okay. So we'll summarize today's. I have a lot of data to show you, but whether to what extent it will be useful to you, I will show you one paper. So before that, I will just conclude my lecture. The key advantages of AI in the pump design. So, like I mentioned the earlier, when there was no CFD, the hydraulic designers were just using the trial and error method. Then came the CFD. Then now it is CFD with the AI that can make the CFD simulation faster. Okay, so it can make your design process faster. Okay, please understand here. Faster design cycle. Okay, simulation accuracy. Okay, like you take the one example of Nokia. Okay, so Nokia's earlier mobile called it as the candy phones were very rough construction and were very popular, but they not invested enough for development of smartphones. Okay, because product development is a long process, and in this long process, if you are late, you may vanish from the market. Okay, so in this way, this AI can help you to build the new product faster, can detect fault, and can make predictive maintenance. You can increase efficiency, or rather, with the AI, we can try to be near to base efficiency operation point. It can increase reliability and, of course, cost saving. So these are the references. If you want, I can show you one paper. So here you can see different studies, optimization studies undertaken with different models of NN means what? Neural network. Okay, different models and what is their contribution or observation. And you can see different ANN structures. Okay, then SVR model, ANN model. So this is one of the review paper. You can go through. I will send you this paper. So what I will suggest is there are different models and methods. So for your study area, select which one is the best one. Okay, so accordingly you choose the model. Like mostly people use a neural network, and in that it is BPNN or okay. So they have shown streamline flow loss distribution in the first stage of impeller, original model, and optimized model. Okay, so we can see the diagram here. What is the difference? Try to observe. So here you can see this right one is better than left one. Okay. We can go through this. So you can see the graph. Optimize case 1, 2, 3. It is optimize is the red one. I've just switch on the marker. So it is the original one. Okay, you can see here. Original one is below. Then here some optimization was done. A red one, optimize case 1. But in optimized case 1, you can see the efficiency not that much good. Then further optimized case 2 and 3, it is efficiency is improved. Okay. So so they have shown with this graph that efficiency can be improved with the optimization and taking the help of the AI. The efficiency sufficiently maybe 5%, 5 to 6% improvement. It's very good. Part load efficiency. Okay. What happens sometimes the pump don't work on the full load, part load, the efficiency will drop. So always try to work as close as possible to the base efficiency. So here you can see that these are different. They use many papers for writing this. So I will stop here. If you have any question, please you can ask me. So I have concluded here.
Dear participants, all are requested to please, if you have any query or if you have any point that should be discussed here, please raise your query. You can also write in the chat box.
So thank you, friends, for listening to my lecture. If you have any question, you can ask. Otherwise, we can conclude here. So AI is future, but without data, without training,
Hello, sir.
nothing is there. Yeah.
Hello.
Hello, sir.
Am I
Hello.
audible, sir?
Hello, sir.
Yes, sir. So it was nice lecture, sir. Just I want to know, for a beginner, we can say, application of AI ML into a mechanical engineering. What are the basic steps required for a beginners like students or beginners? Yes.
So, as I mentioned, you have to select your area. Like here in the pump hydraulics, most of people are using ANN, that is a neural network. So you have to start using the neural network model. Okay. So there are some websites where you can get the data for training purpose. Okay.
Okay.
Like GitHub is there, you can get some data for training. And from that training, you can train your neural network. It may not be from the hydraulic, you can take some data. So we will learn how to conduct the training for particular model. Okay, so we can start like that.
Sure, sir. Thank you.
Sir, one of our participant, Mahesh Kanojia, has asked, is AI presently integrated with CFD?
Yeah, some softwares have integrated AI so that the simulation is faster. Even this we have observed when I was doing PhD in 2007. After first iteration, it was creating some software was creating some field. Okay. But nowadays, AI is helping CFD to give the solution faster. Okay. So that your computation time is reduced. But it is built in. Okay. It is having feature. Okay. I will give some example. I will send you. Okay.
Okay, so
Thank you, sir.
Thank you.
Thank you, Dr. Borse, sir, for
Thank you,
accepting
sir,
our
for inviting
invitation
me.
and delivering such a wonderful session on AI for centrifugal pumps. And that is really very useful session for the participants because the faculty members can take idea from this session to take a projects maybe at UG or PG level or even at PhD level. Thank you so much, sir. Thank you very much.
Thank you for
Now,
inviting.
thank
Yeah.
you, sir. Now there is an instruction to all my dear participants. We are going to conduct the assessment at 5 p.m. Prior to that, we'll have to give the feedback for the entire FDP. Till now, you have given feedback session-wise. Now, I would request to take a feedback from all of you for the 6-day FDP program. And at the same time, most importantly, as per AICTE guidelines, the test is going to be conducted at 5 p.m. That will be of 45 minutes. And after that, there will be a short validatory function also. So all have to remain present for the test. Without test, the certificate award will not be possible. As per guidelines, the attendance and the test performance is important. So I request all my dear participants to please appear for the test, as well as your attendance will be getting monitored. And based on that, entire data is given to AICTE. AICTE is going to give the certificate. It is not by locally by our institute. So please take a note of it. Thank you for that.
Yeah, dear participants, we will mail you the test link, or you can directly visit to the Atal FDP portal, and there you can attend the session at 5 p.m. And if you have any query, you can directly mail us, or you can.
We will provide the details of the test, link and all, everything, whatever communication that will be done directly on the WhatsApp group. So please be in touch with us.
Sir, in the Atal portal, I could not able to fill the feedback because of due to not updating attendance. When you are going to update the attendance, that feedback, the Atal FDP, the feedback I could not able to fill it because of attendance is not updated.
Okay.
We are
when you are going to update that one, then when I have to submit the feedback?
Okay. We are going to see. We are monitoring the attendance session wise, and there is a criteria, no? So it will take some time. That's why we are taking this short break. Because
now in this break you are going to update, yes?
Yeah, of course. During this break we are going to update on the attendance part.
Okay, it will start exactly 5 o'clock, that FDP, yes? That
test. Please be in touch with us through WhatsApp.
5 to 5:45.
Yeah, 5 to 5:45.
Okay, fine. Thank you.
Okay, thank you so much, sir. Dr. Borse, sir, for your kind and informative presentation. It was definitely fruitful.
Oh, sorry. Participants.
Hello. Yes, sir.
Yes, sir.
Yes, sir.
Please give 30 minutes time to us for preparing. I just got the feedback from my team that there is some issue for the attendance updation. The server, there is a problem. So 30 minutes break we will take. 5:30 will start.
5:30 we will start.
Okay, sir. Let us let us get the reminder on WhatsApp group.
Yeah, of course, I will take care of that. Thank you.
Yes. Thank you.
Okay, thank you everyone. You can leave the meeting now. You can take a break. Thank you. Yes.